afternoon, Mr. Richards.
Oh, yeah. You're right. Sorry.
There you go,
It
Kylie.
was like morning.
Yes, Cadence.
Morning, Clayton. Morning, Austin. Thomas, good morning. Kaylee, good morning.
And
Oh, hi, Kaylee.
Hi, Kaylee.
hi, Kaylee.
I'm not saying hi, Kaylee.
I started that trend.
Nope, you didn't.
So a busy day today or pretty relaxed today?
You're our only person.
That is so sad.
Not really.
All right, I shared a document on Google Classroom for the notes for today. So if you want to open that up and we'll talk about stuff on there. Good morning. Can you all go to that Google Classroom? There should be a notes page there for today's meeting.
Yep.
I'm sorry.
Now, last time we met, morning, Justin. We opened up the Google Classroom, Justin. There's a notes page for today.
Somebody tell Mr. Richards it's not morning any longer.
I know. They already corrected me once. I still keep making the mistake.
I did.
Sorry, Mr. Richards, had to give you a hard time there.
Okay, so on, if we look at that worksheet, do you guys have that up and open?
Hey, Mr. Richards.
Yes, Emma. Emma? Emma? Emma, do you have a question?
Yeah.
Okay. So we're gonna look at the page.
Why do we have a well, why not working?
I'm sorry, I can hardly hear you.
Hi.
Did you ask why something?
Okay.
Her audio has been struggling a lot these past few days.
Yes.
Okay. All right, so on the notes for today, 3.26. Let's just review, first of all, the first part there. So we talked last time. Kylie, what do you think? Human chromosomes, how many pairs do they have?
I do not remember.
Don't remember? Aye. Volunteers, how many chromosomes?
6.
How many?
6.
Okay. No, a little bit off there.
46?
Okay, 46, right? So 46 would be how many pairs? Take 40, huh?
23.
23. So that's our first answer. Human chromosome, there's 23 pairs. And we number those pairs from 1 to 23 from their size. So the number 1 pair is the smallest chromosome pair. Right? The number 23 pairs for the sex chromosomes are the largest chromosomes. If you have background, you might want to mute. Okay, so how did we get these Nick's blank 46 chromosomes? All right, so would it be easier if I shared my screen as we go over that document, or is that causing you difficulty?
I think it's easier when you share.
Okay, I'll share my screen, and then again, I'll take over, and you'll probably have to open up a new window. So, but we'll see how that works. Okay. Trying to. Okay, that's different. I don't know really what happened. Am I sharing my screen right now? No?
No, you
All
aren't.
right, try again here.
Now
There?
you. Yeah, you are.
Okay. Okay, so we get those 46 chromosomes, of course, from the process of reproduction, all right? The sperm is going to carry 23 chromosomes from the father. And Drake, what do you think the next blank is? Anybody know the other name for the egg? Kind of a different term. It's called the oocyte, all right? It's probably why we just call it the egg. Okay, Drake, what about that one? So how many single chromosomes from the mom?
Sorry, I was muted. Probably 23.
Probably 23, yes. So we have 23 from the sperm and 23 from the oocyte or the egg. So during fertilization, the next line there, they'll make a zygote with 23 pairs. So 1/2 from your dad, 1/2 from your mom. So you get your 46 chromosomes. All right. We have to define some terms here that we use with the cell cycle. So haploid symbol, and I misspelled it on that document, sorry. The haploid symbol we just use as a lowercase n. And haploid means half. It's half the number of a single set of pairs. So again, if we look at haploid, both the sperm and the egg are haploid. They have just 23 total chromosomes. We okay so far? Okay. If we think about diploid, symbol for diploid is 2 times that number, or 2n. All right, and this is really just defined as the normal number of chromosomes. Right? So we have 23 chromosomes and its pair. So we have, Michael, how many total? "23 single chromosomes and 23 single chromosomes from the mom gives you a total of
46.
46. Now, occasionally when we look at the cell cycle, which the POGL is about, we have to kind of use a term called tetraploid. If you've ever played Tetris, they're made of blocks of 4 squares. So tetraploid is a symbol of 4n, and it is 4 times the haploid. So Zaya, you look like a mathematician. How many would that be total? You're muted. How many?
92.
92, correct. It might seem odd to think of a cell in your body of having 92 chromosomes, but it happens a lot. Right? Now, I'm going to stop sharing for a second so I can hopefully Can you see my whiteboard there?
Very well.
Not very well.
Just yeet those lights off. Yeah, now it's
Any
better.
better? There's a glare though, isn't there?
You can still like kind of see it. You just can't see like the words.
Well, this is the diagram from the first diagram in the Pogel, just the cell cycle. And look at these phases during the G1 phase here, and the cell is just growing. This is where we get our normal number of chromosomes. So during the G1 phase, we have the 46 chromosomes, or 23 pairs. And you can see the cell is, growing in size on that. It's getting bigger, but it started out as a normal cell with our 46 chromosomes, and it ends still with 46 chromosomes. Right? It is diploid. It has the set from the dad, set from the mom, so it has 46 total. Right? It's diploid. Right? But during the S phase, that's the synthesis phase. It's starting to replicate chromosomes. So chromosome number duplicates, and during the S phase is actually tetraploid or 4N. And the G2 is just getting ready to divide. It doesn't last very long, but again, that would be tetraploid also. So we have diploid during G1, tetraploid during S, tetraploid during G2, and now during mitosis, now we're making two cells. So we're splitting that 92 chromosomes so we can get our 46, right? So M1 is when we reduce the number and we go back to the haploid number, right? Does that make any sense? All right, let me try to go back to the notes page here. I'm going to reshare my screen. All right, so let's fill in that part if you haven't already. All right, Austin, G1 phase has how many pairs?
23.
I'm sorry, I can't hear you.
23.
23. So Jenna, that'd be a total of?
46.
46. Right. And ploidy just refers to, is it haploid, is it diploid, is it tetraploid? So what's the ploidy of that, Thomas? Is it N, is it 2N, or is it 4N? Can't hear you.
2N.
2N. Okay, S phase is the synthesis. So synthesis has double its chromosomes. So I guess has doubled its chromosome number. So now we have the 92, and its ploidy is 4N. Again, G2 we just talked about. It's preparing for what, Tyson? I can't hear you.
I think mitosis.
Starts with a D, but mitosis is a pretty good answer.
Diploid. Vision.
Yeah. Right. And G2 is still preparing, so it's still 4N. And then mitosis, the cell division, and cytokinesis. Cytokinesis is, mitosis is when the nucleus divides. Cytokinesis is when the cell splits in half. So ploidy number is reduced back to 2N. Sorry, another spelling error on that. Okay, we've been talking a lot about cancer, both in the labs and then last week and with cell division. Cancer, as the note here says, scientists used to think that cancer speeds up cellular division. And most of chemotherapy and most of the medicines that were used when we started treating cancer were try to slow that process down, not let it, grow so fast. But recently we found out that it doesn't really speed up the process. It prevents this word that you should know, apoptosis. Right? It prevents the cell from dying like it's supposed to. Now, lung tissue has to revitalize or regenerate itself within 3 weeks. It can't just divide forever. And skin tissue, a little bit faster. We talked last time about it was the fastest growing tissue. And blood tissue, 4 months. So skin tissue is pretty fast. Blood tissue is pretty slow. But things have to eventually die off. That's where cancer kind of plays a part. Cancer doesn't let the cell die off. Right? And we talked last time about skin cancer. Someone mentioned melanoma. Does anybody know how to recognize melanoma or what might be a site of normal, of that common skin cancer?
Discolored spots in your skin.
Discolored spots, yeah. Right? Large brown spots. Right? And usually they're dotted or speckled. Whoop. Sorry. Right? Another way to recognize a common melanoma is maybe there's a mole that changes color. There are some other types of skin cancer that we didn't mention last time. Basal cell carcinoma. These can appear on people's skin as like a pearly bump. Or even maybe a sore that heals and returns. Right, and the third and last type of skin cancer is squamous cell. Whoop. Squamous cell carcinoma. Now, we all know what a pustule or a papule is, right? It's a type of acne. So a squamous cell carcinoma is going to look almost like acne. It's going to be like a firm red nodule. So it's not squishy. It's not soft. Okay? It's just like a red bump that appears. Right? Another type of squamous cell carcinoma is maybe a sore on your arm or on skin that gets real scaly. Again, and then these cancers, you think about the epidermis grows so fast. So this is why, skin cancer is the most common. And cancer just prevents cells from dying, so it just grows and grows and grows. All right. I thought maybe we'd talk a little bit about the coronavirus. What do you know about the coronavirus?
It's a
In fact,
respiratory.
just the one that the COVID-19.
Kills a lot of people.
Okay. High mortality rate.
The flu.
It's in Colorado.
It came from people eating
Federal
animals like gummy heads.
Right.
It's respiratory.
It's respiratory. What does it actually do in your body? If we think about the cell and the cell cycle and your DNA, any idea what the virus actually does to your body?
It kills it.
It doesn't.
Oh.
A virus, it injects its DNA into your cells. Because a virus can't reproduce on its own. So it's got to hijack your body cells. And COVID-19 actually hijacks the cells in your respiratory system. Right? Now think about when you have a flu, it's the same, can't spell again, sorry. It's the same thing. When you have a flu, you might cough, you might have trouble breathing, you cough and you have a fever because your body realizes there's something there that it doesn't want. So it tries to get rid of it. The COVID-19, can't scroll up, why not? All right, hold on. Having difficulties. I'm not technologically great here. Okay, the COVID-19 is unlike the flu because it gets deeper into your respiratory system. It infects and what it does is it does almost the same thing that cancer does. It prevents the cell from dying. So it actually, in the cell cycle, it causes mitosis, but prevents apoptosis. It prevents your cells from dying off, so those cells can just start making more and more of the virus. Because what happens is when the virus takes over your DNA, takes over your nucleus, it tells the nucleus to start making more of these viruses. And then the viruses like multiply. And they're made so much that it fills up with these viruses, and then the cell actually bursts and the virus spreads and affects other cells. All right, any questions on that? I'm gonna stop share. Now, you guys okay? All right, how are we doing with the cat labs?
I'm on 8 and 9.
You're 8 and 9. Okay.
I
Hey,
was finally
brought
able to get the videos to work.
You still can't get them?
No, I finally got them to work.
Oh, you did. Okay. Did it help with the direct links so you're not viewing them on Google Classroom?
Yeah.
Okay. I'll keep doing that also. I brought the cat back to school because we're going to start the internal part. So we're all done with the muscular. Okay. Now, you might have to reach out about the knee quiz. I couldn't really think of another way to put that knee diagram on there, on the lab, except by posting another picture of the knee on Google Classroom and have you match up the parts. So, you know, there might be some difficulties with that, but let me know how it goes. After you think you're confident with the knee parts, there is a QIA quiz on the knee parts for you. Okay. Keep on rolling. All right, you guys, have a wonderful day.
See you, Mr. Richards.
See ya.
Yeah.